Remember in 7.1 we looked at diagrams and tables. Now we can start looking at a double number line version, representation of proportional reasoning. So what happens here is that when we have two things, two amounts varying proportionally, which means that there's a constant ratio, then what we can do is we can put those two variables, two quantities, on the double number line. So for example, if we read this question, we have 3 yards of rope weigh 2 pounds, and how much of do the following lengths of the same kind of rope weigh? So if we're looking at two variables, one is length and one is weight, then we would be measuring length in yards and weight in pounds. And we can draw these on our double number line. So we saw that for 2 pounds, the rope is 3 yards. What if we take twice that length? So it would be 4 pounds for 6 yards, right? We could also take 3 times that weight. Does this remind you of the table that we did? So we could do 6 pounds for 9 yards, etc., etc., etc. So let's see if we can answer the questions. A is 18 yards. Well, 18 yards means we're going to be looking at when the length is 18, and that seems to be, it's going to be twice this length, right? So we know that 9 yards was 6 pounds. So if we do another 9 yards, we'd have 18 yards and another 6 pounds, so 12 pounds. What if we have 16 yards or 14 yards? Well, let's fill in the middle steps here. So 12 and 8 and 15 and 10. Okay, so but where is 16 yards? Right? You see that it would be right here. 16 yards. It would be in the middle, a little too closer to the 15 yards. So we need to know, we know that this much rope will weigh 10 pounds. What happens if we add another yard? Well, this is going to be where we need to find how much 1 yard of rope weighs. And we can do that by going back. So we say 3 yards weighs 2 pounds. So 1 yard will weigh 2/3 pound, and 2 yards will weigh 4/3 of a pound. So if we know that 15 yards weighs 10 pounds, well, that extra 1 yard is going to weigh an extra 2/3 pounds. So 10 and 2/3. Okay. Now notice that the 2/3 of the pound, right here, there's a connection between our 2/3 of the pound and our 3 yards for 2 pounds relationship. We can follow through that kind of strategy as we try to solve the next problems. Okay. Now, I'm going to leave C for you to figure out and complete after you watch this video. All right, let's look at number 2. If 2 meters of wire weighs 24.8 grams, then how much do 15 meters of that same kind of wire weigh? Try to find several ways of reasoning about the quantities to solve this problem. Let's see. If 2 meters of wire weighs 24.8 grams, so 2 meters weighs 24.8 grams. We want to know 15 meters. Well, if 2 meters weighs 24.8 grams, then how much does 1 meter weigh? All right, wouldn't that be 12.4 grams? So we should be able to then figure out how much 15 meters weigh. Because if 1 meter weighs 12.4 grams, then 15 meters will weigh 15 times 12.4 grams. And you can figure that out. We could have also done this on the number line. So we knew that 0, 0, and if this is length, and this is weight, then the 2 meters, it's 24.8. We can certainly figure out what 14 meters would be. That's 7 times 24.8. And then we needed to add 1 more meter, right? Which we could have figured out. Here, 1 meter is 12.4 grams. Okay, so I will leave this for you to formalize, right? This is some sketch marks and some strategy, but you need to formalize it in order to be able to write out the final answer. Now, for number 3, a scooter is going 3/4 of a mile every 4 minutes. How far does the scooter go in the following amounts of time? Well, let's see if we can use a double number line for this. So it's going 3/4 of a mile for every minute. So this is going to be a distance, and this is time, and this is miles, and this is minutes. So we know that for every 4 minutes, it goes 3/4 of a mile. How far does the scooter go in 12 minutes? Well, if he doesn't slow down, this would be 3/2. And then at 12 minutes, it would be 3 times that, right? So 9/4. Right, notice that we took 3 of these and 3 of these, right? Because it's the same speed. So 9/4 miles, which is 2.25 miles. How would you figure out 17 minutes? I know we could get 16 minutes. 3 miles. All right, but how would you be able to get 17 minutes? So I'd like you to go back to what we did with number 2 and see if you can figure this out. Now, how long does it take the scooter to go the following distance? 1 mile. So let's switch to a different color. 1 mile. So this is distance and time. This is miles and minutes. And we know that 3/4 of a mile takes 4 minutes. Now we want to know how long it would take to do 1 mile. Well, there are a couple of ways we can do that too. So for example, now if we want to know what 1 mile is, could we figure out what 1/4 of a mile would be? There are 3/4 in this distance of a mile, 3/4. So if we want to do 1/4, we would need to take 1/3 of that. Right? Now, if we want to find the 1 mile, then it's going to be 4 1/4. So this is going to be multiplied by 4. So this would be 16/3 of a minute. So 3 1/4 minute. Okay. And I'm going to leave it up to you to do question B. So now we have done diagrams, we've done tables, we've done double number lines. Now there's yet another representation, which is called strip diagrams. That comes from Singapore math. They use strip diagrams a lot. And it's a way to represent quantities just using regular rectangular blocks. So let's see what happens here. Suppose a certain shade of green paint is made by mixing blue paint with yellow paint in a ratio of 2 to 3. Now, where is our ratio of 2 to 3 in this picture? All right, so notice that there are 2 of the blocks here and 3 of the blocks here. So if we mix up that much blue paint and that much yellow paint, we will have a ratio of 2 to 3. So for each of parts A, B, and C, use the same shade of green paint as above, which is made by mixing blue paint with yellow paint in a ratio of 2:3. Explain how to solve the problem by using the strip diagram. So if you use 26 pails of blue paint, let's see if we can make sense of this. So this is blue, and this is yellow. So if the blue paint is 26 pails, how much yellow paint do you need? Well, sure, we could go do the proportional reasoning, but here it's actually going to be a little bit easier to say, well, if the two blue blocks are 26 pails, then wouldn't that mean that this is 13 pails and this is 13 pails? And if we're counting a ratio of 2:3, then we should be counting the same unit in both blue and yellow paint. So shouldn't this also be 13s? Then each of the rectangles will be 13 pails. So how much of the yellow paint? Well, 39 pails. Notice that we've made sense of this not by proportions, not by cross-multiplying, not by doing anything else like that. We made sense of it by drawing a diagram. So if you have 48 pails of yellow paint, how many pails of blue paint will you need? I'm going to leave that one for you. So you can pause the video and figure out the answer to this and respond. If you want to make 125 pails of green paint, how many pails of paint, of blue paint and yellow paint will you need? So let's see if we have a total of 125. So this is blue, this is yellow, and the total is 125. Well, if the total is 125 and we have 5 blocks of paint, 5 amounts of paint going in, parts of paint going in, so 1, 2, 3, 4, 5, 2 of them are blue and 3 of them are yellow, then wouldn't that make sense that in order to make 125, each one of these blocks should be 25? All right, so each one of those is 25. So if the ratio holds, then we should have 75 pails of blue and, oh, not 75 pails of blue, 50 pails of blue and 75 pails of yellow. Now, number 2, I'm going to leave for you to work out and submit in the final question. Okay, now let's take a look at another problem. Solving proportion problems by reasoning about multiplication and division with quantities. So we have a paint problem again. The paint company makes peony pink paint by mixing red and white paint in the ratio of 4:7. How many liters of white paint does the company need to mix with 35 liters of red paint to make the peony pink? So solve the paint problem by reasoning about multiplication and division with quantities in any way that you can. In each case, describe the number of liters of white paint that is produced, AB, where A and B are suitable whole numbers, fractions, mixed numbers, that you derive from 4 and 7 and 35. So attend carefully to our definition of multiplication. When you use division, explain what kind it is. Use math drawing to support your explanation. Okay, so we really need to dive in deeply into this particular problem. Well, let's see. If we draw it, we have 4 red and 7 white. Okay, 4 red and 7 white. And what they tell us is that how many liters of white paint does a company need to mix 35 liters of red paint? So 35 liters of red paint. Okay. So how many liters of white paint does the company need to mix with 35 liters of red paint? And we want to know how much white paint. So what we can do here is we could say, all right, well, there was 4 blocks of red paint, 4 parts of red paint to 7 parts of white paint. So if we were to split 4 parts of red paint, 35 between 4 parts, we're going to have each one of these, so 32 between 4 parts is 8 3/4. Now, how did we get 8 3/4? Right? Do you see that it's 8 3/4? Right, you have 8 3/4 and 8 3/4. It's 17 and a half, and another 17 and a half will give us 35. But how did we get that? If not, saying 35 divided by 4 is 8 3/4. Okay, so we have 4 parts in our 35 pails of red paint. Now, if we have the same to figure out for white, then we'll actually have 7 of those 8 3/4. Right? And we can figure out what that is. So 7 times 8, right, and 3/4. You should be able to figure it out, and you can write that answer out here. Okay, so we had a division situation here in the red. We had the total was 35. We knew we had 4 groups. We wanted to know how many in each group. And for the last one, for the multiplication, we knew we had 7 groups of 8 3/4, and we wanted to know the total number. And again, I'm going to ask you to flesh out your notes in this to make sure that you have good notes for this particular activity. Now let's look a little bit more at our strip diagrams and have a little bit more practice. So at lunch, there was a choice of pizza or hot dog. 3 times as many students chose pizza as chose hot dogs. Together, 160 students got lunch. How many students got pizza and how many got a hot dog? Draw a strip diagram to help you solve the problem. So let's see if we have a strip diagram. So we have pizza and hot dog, and 3 times as many students chose pizza as hot dog. So if hot dog was this much, then pizza would be that much. Altogether, 160 students ate lunch. How many students got pizza and how many students got hot dog? So let's see, we have 4 groups, right, of some students that with the total number of students being 160. So what we need to do is we need to take 160 divided by 4 groups to figure out how many in each group, and that's 40. 40 in each group. So then for the pizza, we have 3 groups of 40. And for the hot dog, we have 1 group of 40. So we had 40 kids asking for a hot dog and 120 kids asking for pizza. I'm going to leave number 2 for you to work out, and I'm going to do number 3. So take your time to work out number 2, and then let's talk about number 3. The ratio of Shantae's cards to Jessica's cards is 5-2. After Shantae gives Jessica 12 of her cards, both girls have the same number of cards. How many cards do Shantae and Jessica each have now? Draw a strip diagram to help you solve this problem. Okay, so Shantae and Jessica has 2 groups, and Shantae has 5 groups. So 5-2. Now, after Shantae gives 12 of her cards to Jessica, so she's going to give 12 cards to Jessica. They will be equal. So that means that she needs to cut the difference in half, right? So that they would be equal. So, and that is 12. So 12 was actually how many cards there were in 1.5 groups. Right, so one group then has 8 cards. So how many in each group if you have 12 items and there are 1.5 per group? 1.5 groups. So then each one of these would be 8, 8, and then this is 4. Actually, this would be 4 and 4 if I drew it split up already. So how many cards do Shantae and Jessica have now? Well, 8 times 3 plus 4, right? So 28. Jessica. Okay, and for Shantae, we have, well, 28 as well. Okay, and again, take a minute to finish up writing out question 3, and then I would like you to work on question 4. Finally, let's take a look at 7F in this section. And I'll do one of the questions with you, and then I would like you to do the other one. Chandra made a milkshake by mixing half a cup of ice cream with 3/4 cups of milk. Reason about the quantities to determine how many cups of ice cream and milk Chandra could use if she wants to make the same milkshake with the following amounts: 3 cups of ice cream, or to make 3 cups of milkshake. So let's split this up. This is A, and this is B. So first of all, take a look and see if you can solve this problem on your own. Now, she is mixing half a cup of ice cream with 3/4 cup of milk. So we got I can use a double number line. Ice cream, milkshake. Oh, no, mix. By milk. Milk. So half a cup of ice cream, 3/4 cups of milk. Using 3 cups of ice cream, how much milk is she going to need? Let's see if we can figure that out. So using 3 cups of ice cream, so this would be 1 cup. That's 3 halves. This would be 1.5 cup. Right, this would be 2 cups. And then this would be 2.5, and this would be 3 cups. Okay. Well, if 1 cup of ice cream went with 3 halves of milk, then 3 cups of ice cream would go with 9 halves of milk. Okay. So we would have 9 halves cups of milk, or 4.5 cups of milk. To make the 3 cups of milkshake, that's a little bit more challenging. Let's see if we can figure that out as well. So, apologies for my cat. Ice cream, milk, and we're going to have a total here of ice cream and milk to see how much milkshake we have. And we know that 1/2 of ice cream with 3/4 of milk. Now the overall here is 1/2 and 3/4 is 1 1/4. It's not really a pretty number for the total of milkshake. So let's try 1 and 6/4, or 3 halves. So this would be 5 halves, or okay, so 5 halves, or 2.5. Again, not quite 3. How about we try 1.5, and this would be 9/4. Now the sum of that is, so 3 halves and 9/4. So it would be 6/4 and 9/4, so 15/4. That's 3 3/4. And the numbers are still not very nice. So let's try to go one more bit. So 2 and 3. Ooh, look at that. When we have 2 cups of ice cream, we would need to put 3 cups of milk. So that's an interesting relationship to note, this one. But we don't need that much. We only need 3 cups of milk. So, of milkshake. So for ice cream, we would need to take 2, but we only need 3 cups, not 5 cups total. So we would divide out the 5 and multiply by 3, right? So what would be a fifth of that amount? And we only need 3 of those fifths. Okay, so that is 6/5. And for a milkshake, we would have 3 divided by 5 times 3. That would be 9/5. So 6/5 of ice cream and 9/5 of milkshake will give us 15/5, which is 3 cups of milkshake.